Okay, this is 6-8, I believe. And this is synthetic division, but what I'm going to do is do a long division first and then do the same problem synthetically with synthetic division. Just so we review 6-7 a bit since it's been a couple days. And then a long division. So let's do this one. Right in a straight line, that would be great. Okay, so x minus 1 is the factor that we're trying to divide into this polynomial. The purpose of synthetic division and long division and dividing factors into polynomials is to see if they are zeros, because that will tell us where this graph crosses the x-axis. Okay, if the remainder is 0, then the factor that you put in, the solution to that factor is a 0 for that polynomial. All right, so long division, this goes outside. And with this problem, remember, if it starts at 5, it has to go down sequentially by 1. If it doesn't, you have to put a placeholder in. So do you see how I'm missing an x to the 4th and an x squared term? Okay, so I'm going to put in 3x to the 5th plus 0 x to the 4th plus 4x cubed plus 0 x squared minus x minus 2. I have to put placeholders in for the missing exponents. Okay, and when I start this, the only thing I'm worrying about is this first term and what times this first term is equal to this first term. Yep. Okay. Yep. So 3x to the 4th times x is 3x to the 5th. This is the first time you can check your work because it should match up. And 3x to the 4th times negative 1 is negative 3x to the 4th. Change your signs and add. So I get 3x to the 4th, and then I bring down the next term. X times what is 3x to the 4th?
3x.
Uh-huh. Okay, 3x to the 4th minus 3x cubed. Change my signs, and I get 7x cubed plus 0x squared. X times what is 7x cubed? 7x squared. Seven x squared times x is 7x cubed. 7x squared times negative 1 is negative 7x squared. Change my signs, add. Break down my next term. 7x times x is 7x squared times negative 1 is negative 7x. Change my signs and add. X times what is 6x? 6. And that becomes 6x minus 6. Change my signs. My remainder is 4. So it's not a 0. But if I want to divide this, how I would write my answer is this whole polynomial plus 4 over x minus 1. It's the formal way of your answer, writing your answer. Okay. In web work, they just want this number. You wish what?
It wasn't so long.
Yeah. Well, I started a long one. Sometimes it's a cubic and it's not quite as long. But I wanted to do this one just to remind you about the placeholder. Okay. Now we're going to talk about synthetic division. I don't think you need one because you can work on that workbook. All right. Synthetic division, same problem. What I'm going to do with synthetic division in the problem is I don't write the whole term, I just write the coefficient. Okay, so that's the first thing that you're going to do. And you still need placeholders. So if my problem was this long one, 3x to the 5th plus 4x cubed minus x minus 2 divided by x minus 1, I'm going to just write I've got a problem here. 3 is my first coefficient. 0 is my x to the 4th. 4 is my x cubed coefficient. 0 is my x squared. Negative 1 is my x, and negative 2 is my constant. So I'm just writing the numbers. I'm not dealing with the terms. That's the first thing that's different.
And then we're not going to use x to divide.
Right. So now, if I'm, and this really only works if I'm going to divide by a 1 degree term, 1 degree expression. What I mean by that is if I want to divide by x squared plus 2, I can't use synthetic. Okay? It has to be x plus something, x minus something for synthetic to work. Okay? So what you're going to do is you're going to just draw this little box. And when I'm doing long division, if this is what I'm dividing by, that's what I write outside as the divisor. But with synthetic division, I'm actually going to use the solution to this. So if I set this equal to 0, the solution is 1. That's what goes in the box. These two mean the same thing. This is what I use for synthetic. This is what I use for long division, and they mean the same thing. With synthetic, I'm using the solution, and with long division, I'm using the factor. Does that make sense? Okay. Then I'm just going to draw this line. And the first step, I just bring down the first number. I don't do anything but bring it down. Okay? Now, I'm going to take that number, and I'm going to multiply it by 1, whatever's in the box, and I'm going to write that number in the next column. Then I'm going to add these two numbers. 0 plus 3 is 3. Then I'm going to take 3, and I'm going to multiply it by 1, put it in this column, and I'm going to add the two numbers, 7. Take 7, multiply it by 1, add it here, add these two numbers. Take 7, multiply it by 1, put it here, add these two numbers. Take 6, multiply it by 1, put it here, add these two numbers. Now I have to interpret what this means. I started with an x to the 5th term. If I'm doing this one time, it's going to drop the degree by 1. So this is an x to the 4th. So now I can put my answer, 3x to the 4th plus 3x cubed plus 7x squared plus 7x plus 6, remainder 4. Three x to the 4th plus 3x cubed plus 7x squared plus 7x plus 6, remainder 4. Mind blown, right? Okay, this is synthetic division. We did long division before. You need to know how to do both for a quiz, because I'll say specifically using long division so I can see your work. But if you had to choose, this is the method you would more than likely choose. And when we go forward with our using division to find zeros, and we have to do it over and over and over again to find one that works, you're going to want to use this method over long division because it's a lot faster. The other cool thing about synthetic division is this is function notation, right? If my function notation was, and I gave you this function, 3x to the 5th plus 4x cubed minus x minus 2. Okay? If I gave you that function and I said find f of 1, what does that mean? We're going to do functions later on in this semester.
Equals 1.
You're close. It's not f equals 1.
0.
It's f of x, and I replaced x with 1. So I want to know what this is equal to when x is 1. Okay? It's not so bad when it's 1, because 1 to the 5th times 3 plus 1 to the 3rd times 4 minus 1 minus 1, right? But if this number was 27, and you're having to do 27 to the 5th times 3 plus 27 cubed times 4 minus 27 minus 1, it gets really big. Well, what's really cool with synthetic division, 1 was what I chose here, right? And my remainder was 4. If I put 1 in for x here, My answer is 4. 1 times 3. 1 times 4. Minus 1 minus 1.
7, 6, 5.
That's 5. That didn't work. 1 times 3 is 3. 1 times 4. Minus 1 minus 1. Why didn't that work? Did I write my problem down wrong? Oh, yes, I did.
There it is.
Wrote my problem down wrong.
4.
It is 4.
5.
So you can use synthetic division when you have a really big polynomial and they want you to put a number in for x. Otherwise, you're on the calculator going, okay, this number raised to the 5th times this, plus this number raised to the 4th times this. It takes you a lot longer than just writing the coefficients down, doing the problem. You're going to get really fast at this.
Yeah.
You get to your remainder, that number is actually the same as if you plugged in that number into the function and solve for y, basically. So that's another feature of synthetic
So
division that's pretty cool.
27, if we did synthetic and it was 27, our answer would be our remainder.
I'd put 27 in here and then do the whole problem just like I did, but using 27. Whatever I get at the end is what is the same answer as if I plug 27 in for x everywhere. So that's kind of cool. Should we do another synthetic problem for practice? One more, and then I'll turn you loose.
You're always on Monday.
Okay.
Why are you going?
You have show card competition.
Okay.
Oh, I didn't give up on that. Thank heavens. Oh, wow.
Lucky.
Okay, so I'm going to write the coefficients. I notice that they are in decreasing order. I don't have any placeholders I have to worry about. And what number goes here? Negative 9. The factor is x plus 9, but the number I put in for synthetic is what the solution is to that factor, which is negative 9. Okay. Bring 2 down to start. 2 times negative 9, negative 18, which becomes negative 33. 33 times 9, 297. Positive. And minus 30, I should know that one, 267, times negative 9, 2403. Add those. 2423 times negative 9, 21807 plus 42.
You used really big numbers.
Okay, it's obvious to me this is not a 0 of this polynomial. Okay, but what would if I asked you what is f of negative 9 of this whole function, the answer would be 21,849. My other choice would be to take negative 9 in my calculator and put negative 9 to the 4th times 2 minus 15 times negative 9 to the 3rd minus 30 times negative 9 squared and so on. I would get the same thing.
So the last number is either our remainder
Or the solution at that point, at that x value. Okay, what we're going to be working on now is using this tool to actually find zeros, and that'll be next week, to actually find the zeros. And you're going to get really good at this because we're going to be doing it over and over and over again, finding zeros. Okay, because if negative 9 is not a 0, then I need to find one that is. So I'm going to try negative 8. I might try 1. I might try 2. I might try negative 4. I'm going to keep going until I get a 0 with no remainder.
There's
Okay.
no network.
Okay, I'll open it real quick.
Can you open it? 27.
Mm-hmm.